Morning. Today, the topic is band theory of solids. In the central idea, if fluidic potential associate in the crystalline lattice, there are allowed and disallowed energy band is there. We have found the possible band and band gaps are there. Certain bands will be filled and certain bands are not filled. If an allowed band is completely empty of electron, there are no electron in the band to participate in the electrical conduction. This can happen, for an example, in high energy band, where the energy of the band are above the energy of any type of system in electron. Perhaps bit more surprising, if the allowed band is completely filled with the electron, those electrons cannot contribute to electric conduction either. This is because electrons are fermions and must obey the Pauli's exclusion principle, so that no two electrons can be in the same state. Therefore, if an electron is given energy due to a say voltage applied to the material, the electron must move to high energy state. If all the states are already filled, the electron has no empty state to move into. And therefore, electron cannot gain energy and contribute to the conduction. So, band of energy that are much less than the Fermi energy of the system's electron, this is would be the conduction. So, no conduction can take place in material that has energy band are either completely filled or completely empty. Thus, we left to conclude the only electron in partially filled energy band can contribute to the conduction. So, conduction only happen when the electron is partially filled. In general, lower band of the material will completely filled with electron and the upper band is partially filled. Material that have partially filled uppermost band are called conductor. Mostly metals are there, such that when energy is supplied by an external source, electrons can move into a higher unoccupied state within the band. A real space band diagram. This is the real space band structure diagram. And here the partially filled is there and uppermost level is called the Fermi level at T equal to 0 Kelvin. The work function E phi is the energy difference between the vacuum level, is the vacuum level energy, and the Fermi level of the energy at T equal to 0 Kelvin. This energy is called the work function. So it is thus the energy needed to completely liberate an electron from the metal or conductor at T equal to 0 Kelvin. And that given the narrow tail of Fermi-Dirac distribution. Okay. So Einstein equation is that H line omega equal to E phi plus E kinetic energy. So if a photoelectric effect example, if a photon of energy H line omega is incident on a metal, so work function is equal to E phi and the kinetic energy of electron equal to E K E. Now, this is the band structure of a typical semiconductor. Semiconductor and insulator band structure are nearly same. The only difference is the band gap, energy band gap, that is different. So its fully filled band is there and fully empty band is there. The uppermost fully filled band is called a valence band, and that's up. There's an empty band is there after a certain gap. This empty band is called the conduction band. And between the top of the valence band and the bottom of the conduction band is the band gap energy, that is denoted by Eg. At 0 degree Kelvin, semiconductor called typically the band gap energy near about 1 electron volt. And if the energy band gap is too large, that is near about 8 electron volt, that is all typically insulated. Okay. So for silicon, silicon 1.12 electron volt band gap, gallium arsenide that is equal to 1.43 electron volt band gap. And for insulator near about 8 electron volt band gap. And now if we apply T greater than 0, then band structure of semiconductor becomes valence band becomes partially filled and conduction band becomes partially filled. So there is a two energy band created, that is partially filled valence band and partially filled conduction band. And it's come to the know whenever it's a semiconductor greater than 0, in spite of what function, it becomes a electron affinity E eta. So whenever conduction is done, then some portion of hole is moving from the valence band and some portion of electron is moving to conduction band. In this way, semiconductor will conduct. Thank you.